Good morning, everyone. Good evening, and good afternoon. Let me share my keynote. Are you able to see my screen?
Yes, ma'am, we can see it.
Yeah, thank you. So, hello everyone. I'm Trupti Raikar, and I'm a SAP technology architect and an independent researcher. Today, I'm here to talk about my one of the study ethics of AI based on supply chain optimization, a better balance between the efficiency and fairness. So, we all know like supply
Excuse
chain
me,
marketing
ma'am.
today.
Have you shared your PPT? We can see
Uh,
your screen, but we can't see the PPT still.
is it okay? Let me try to share it again.
Yeah.
Mm, so- So, are you able to see my screen?
Yes, ma'am, we can see it now.
Okay. So, in today's world, as we all know, that AI has occupied the supply chain market, and by 2020, it is going to reach $18.2 billion. 2027, it is going to reach by $18.2 billion. So AI is using like ML, predictive analytics, and language processing, and due to which AI is yielding a lot of efficiency in supply chain market. But then there are core risks. Algorithms are embedding existing biases like demographic biases and distribution biases, etc., as well as they are being threat for the workers who are low skilled. So the low skilled jobs are being replaced by the AI. So there needs some ethical principles for the fairness and transparency, as well as the accountability and the responsibility. So, coming to AI technologies, like in supply chain, like 60% of retailers have already used AI, and they are finding a lot of efficiency in demand forecasting. Deep neural networks analyzes large data sets, and it reduces the stockouts and overstocks. Whereas in route optimization, RL, that is reinforcement learning, is being adapted that reduces the fuel cost and lead times. Where also in real-time inventory, automated tracking is giving a lot of enhanced results in the resource allocation and handling the dynamic uncertain conditions, as well as in the flexible pricing model. Again, like the uncertain conditions like competitive dynamics of the market, demand spikes are all being measured by the algorithms, and that is giving a lot of margin over the manual inputs. But then the ethical concerns in the AI comes. So when it comes to efficiency, yeah, the efficiency is increasing, but then the ethical concerns are also there. And those concerns are like biases. So there could be biases over the popular product with the least used product. There will be demographic biases, like rich data regions are getting favor from the AI algorithms because they have got a lot of historical data and data privileges. But then the unprivileged areas where historical data doesn't exist. So there are like some biases are there in the AI decisions. Also, AI being a threat for the low skilled workers, and it is estimated that over 20 years of time, like approximately 16 million jobs are going to get replaced by AI. So we need an ethical AI framework for which with which we can achieve the fairness, transparency, accountability, and responsibleness. So again, like for accountability and responsible AI models, the human in your loop is something very important. Also for the transparency, like AI should explain the reasons for why the reasons are being taken. Like AI should have the reasons for every of that of its decisions. Also, the fairness, like there should be kind of equal distribution in the supply, and then there should be demographical parity and equal opportunity for all the areas, all the groups using the AI algorithms. But to implement this ethical framework, there are implementation challenges. Like 40% of organization doesn't have the knowledge or expertise for deploying the ethical AI frameworks, as well as the cost and complexity is also very high in training the human resources with the AI skills, as well as the setups and environments required for AI, like GPUs, clouds, and all, as well as the continuous iterative monitoring, also having the human in loop, are happening, but then they are happening currently after post deployment. But then they should be involved within the AI models so that the AI models will continuously learn and improvise over a period of time. So, Chinna, a lot of literature or studies are being conducted for technical optimizations, but then a lack of some lacks are there still in ethical principles, like operational guidance. Like models will work very well in the lab setups, but when it comes to real world, they will fail. Also, like human oversights are missing, or they are being done post deployment, but then companies have to bear a lot due to these 5 to 10% of unfairness or bias. So also long-term impacts are also not being evaluated well in these studies. So there are different methods and techniques we use in technical efficiency for implementing the AI. Like the major areas of the supply chain are demand forecasting, inventory prediction, and sequential decisions. Like in the demand forecasting, predicting the future trends, inventory predictions, in that like cost and demand relationships should be studied and predicted. Also, uncertain conditions, dynamic conditions should be adapted well in the sequential decisions. So all these things AI does with these algorithms. Like for demand forecasting, AI is using the random forest method, and then gradient boosting is used for inventory prediction. So reinforcement learning is being used for sequential decisions. But then we did a couple of studies, and we did conducted some on-job projects. We found that the random forest can give accuracy, better accuracy by having the depth of around 12 tree nodes with 200 Ts, whereas in gradient boosting, it was like sequential tree evaluation, where if it has some 300 estimators were being used and 0.05% of continuous learning is being used, then the model can continuously learn and it can give a better results. Also in reinforcement, this majorly we use in the policies and non-statutory environments to adapt the policies and non-statutory environments, and it reduces the cost by 21 to 30%. There were challenges with the data while conducting these studies. Like the data were vulnerable. There were like missing data, which led to the inaccurate predictions. Also, the customer behaviors. Like we will be having the data, historical data, which is having the customer behavior for the prioritized regions, or like prioritized set of product, prioritized set of group of people, prioritized set of customers, but then the unprivileged group will suffer due to these data. So there are different mitigation techniques that can be used to overcome these things like data related challenges, and those were like imputations, moat, and GAN. So, to detecting and correcting the fairness and biases, there are different techniques like fairness through unawareness, where it hides the or ignores the sensitive data in the algorithm, and ignoring the sensitive data like race and gender, it will produces the outcomes. So, basically, the outcome will not depend on this biased sensitive data. Also, the adversarial debiasing, that as is another technique where the primary model will have some outcome, and that will be fed to the adversarial model, and then the adversarial model will try to find out the sensitive data from the outcome. And if it finds out that, then the primary model will understands that, okay, the result is based on some sensitive data, and I have to try to get out that sensitive data. So these are few of the techniques, and also the fairness constraints like statistical parity differences and disparate impact ratios that can be imposed on the algorithm, so that the fairness and then unbiasedness can be mitigated. So these are a couple of API assessment standards, like operational efficiency KPIs can be the cost, time, and order fulfillment accuracy, inventory optimization, whereas the fairness KPIs can be equal opportunities for all the demographic groups and disparate impact ratios to have the so that the unprivileged region can be benefited. The decision will be same for the unprivileged and the privileged areas. So for that, we will have to use the multi-objective framework and transparency. For that, Pareto front analysis can be used, which will balance the outcome based on the efficiency as well as the fairness constraints. And we can also implement the explainable AIs, which will give the reasons for all the decisions the AI has taken. So there are many case studies have been conducted, like Pfizer, Amazon, and Walmart had conducted the case studies, and also for implementing the AI, as well as some ethics were being involved, ethical constraints were being involved in their case studies, and also the zipline drones were Reliance Retail were being used, so that the faster delivery can be achieved. That increased the cost, reduction as well as the delivery accuracy, but then again the biases were the same. Also in the medtech technologies, also Pfizer has used the AI, and it achieved the 15% efficiency by reducing the waste. Also AI models were being used in med technologies to anticipate the demand fluctuation and keep going the business without any impact. So that, but still there were been allocation imbalances with and risks were there. Also in the retail, algorithms were used for the efficiency, but data proxies, those are again sensitive data, have led to some biased and unfair outcomes or decisions, and these can be overcome as a trade-off. These can be overcome by fairness constraint, right, disparate impact ratios, and other things. So but then here, if we go with the trade-off between the efficiency and the unbiasedness and fairness, there could be some impact on the revenue. Like there were some impact on the revenue in the retail and e-commerce, that was 1 to 3% of revenue was reduced. in healthcare also, like in one of the Cleveland case, at the time of pandemic, they achieved around 12% of increase in the efficiency in supplying the medicines to the different patients based on the patient conditions, and hospitals based on the capacity. But then again, it was being criticized, like richer area hospitals are getting more supplies than the poorer areas. So there is where, like, governance practices were required for the transparency, bias sensitive learning of the AI, and human oversight, and continuous monitoring. So the lesson learns are like the same, like again, algorithm biases should be removed, and the transparency gap should be addressed. Black box models should be replaced with the explainable AIs, and accountability, transparency has to be increased. Insufficient monitoring were being found, so continuous monitoring is required for those applications. So we had conducted a project where, like, we had compared two groups with A/B test. We implemented the A/B testing framework, where we compared in the around 20 company data, which were spread across retail, pharma, and manufacturing. The group A was like a conventional rule-based AI, whereas group B was like machine learning and reinforcement learning kind of algorithms were being implemented. And the duration was, this experiment was for around 3 months, which was using the 12 months wide historical data. And it has this study had used demand forecasting, gradient boosting for the demand, random forest and gradient boosting for the demand forecasting. And for warehouse automation, it had used the reinforcement learning. So here, like, we have compared the results with the KPIs using the T-test model, Mann-Whitney U-test models. And then we found, also it was reported, the effect of, like, a confidence interval, whatever we found was 90% of time was accurate, and the p-value was like very reliable. So coming to the experiment challenges, we faced the data consistency related challenges, like lack of data was there for rural remote areas, and the same set of data were there, which led to the inaccuracy in the predictions. Also, there were some biases due to the historical patterns. It did not involve all kind of patterns, like for the unprivileged groups. So that was some shortcomings that we faced. But to mitigate these things, like federated learnings and transfer learnings and operational monitoring can be used. So where, like, sharing the sensitive data will be, exposing the sensitive data will be avoided, but then the learning from the AI model can be inherited from the previous AI models. Also transferring, like, if there is a lack of data for the unprivileged areas, then the learning from the high privilege area can be adopted, as well as it can be enhanced. And the continuous monitoring, like the AI will keep learning from its own executions, and then it will learn, okay, this is something which it shouldn't do, this is something it should do. This kind of, like, continuous monitoring of the AI models can improve the challenges. So there are always been, like, high demand, high value segments, high popular product, and then high value customers. There will be some fairness related challenges, but this can be addressed with the Pareto trade-off, as I already said in my previous slide. Like, distributive fairness with versus operational efficiency can be compared, and a balanced outcome can be identified. But then, yeah, there will be some revenue related reductions will be there. So impact of the workforce enhanced employment, like World Employment Force 2025 has predicted that around half of the business jobs will be cut, but then they will be like routine tasks which can be easily automated. But it has also predicted that around if it is 92 million jobs were cut, then 170 million new jobs will come. That is around 78 million new jobs will be introduced globally. But then only thing is that the low skilled workers will be replaced, and they have to invest in reskilling themselves so that they can tackle with the new opportunities. So there were practical difficulties in adopting this ethical AI. Like 45% of executives reported that notable operational challenges as well as like internal oppositions from the workforce in adopting these AI systems. But then there were like also there were like gaps in policies, benchmarking, as well as adapting the explainable AI was like kind of expensive, and there were not enough skills in the organization to do these things. So the future approaches like human in loop was also is one of the other difficulties. Like continuously a human has to audit all the decisions, and until the AI get trained well in the decision making. So the breakthrough, like we also found that okay, yeah, quantum computing can be introduced for the precision of the routing, scheduling, and inventory allocations, and to resolve the complex issues, to handle like complex algorithms. Also, like quantum approximate optimization algorithms can also be applied for NP hard graph problems, that is like last milestone deliveries or port scheduling, in such cases where it cannot be put that easily in the graph. Such for that QA OA applications also can be introduced. So also for ethical AI, we would need rules and standards, and there are like standardized regulations across global supply chain. European AI Act is risk-based rule that can be applied, that is getting applied and can be better applied. US has its own some governances which are sector specific and based on executive directions. China is also focusing on algorithms based on the accountability of the AI, security, and state compliances. Also, there are tools like ISO IEC 23849 for the risk management, AI risk management, and ISO 42001 for AI management systems. So also there are scorecard techniques like fairness matrix, audit data audit frequencies, like other technique, human oversight rates, so explainable coverage. So these all things have to be implemented in AI supply chain. So human oversight is something important, like having the human in loop at the end of the decision making, so that there could be some responsibleness on the algorithms. Like there should be like humans intervention to supervise the AI decisions, AI choices, and also like detecting and correcting the AI models. So we would need human oversight and internationalization for better balance. As a conclusion of this research, we found that yeah, the operational efficiency is achieved, like order fulfillment accuracy with the AI is increased by 20 to 50%. Logistic cost reduction is reduced, is done by 15 to 20%, and customer satisfaction has really gone up by plus 65%. But then also like persistent ethical risks will be there for unequal allocations, unequal supplies, demographic challenges. So the final contribution is like, yeah, like other beyond the cost minimization, the AI models also should be designed such that the design with the fairness constraint, bias identification, having the human authority, and having the accountability within the optimization framework itself. So that is all about the ethics of AI in supply chain optimization. Thank you, everyone. So if you have any questions, please let me know.
Thank you, Ms. Trupti Raikar, for that insightful session. Your perspective on ethical AI and supply chain system was very valuable. We appreciate your time and contribution to this conference. Thank you so much.
Thank you.